Hello all, myself Suresh Kumar. This is our 21st class. In this class, we will discuss about I2c protocol. I2c, what is in I2c? I2c or I2c, we are calling I2c or I2c or inter-integrated circuit. This is we can call also two-wire communication. It has only two wire. One is SCL and another one is SDA. SCL stands for serial clock line and the SDA stands for serial data line. This is invented by Philips. This is a two-wire communication. We can use this protocol and we can connect it and we can interface with our microcontroller from 0 to 127 devices in two wire connected with just two wire. Now in this video, in this class, I will interface the Tc74 thermal sensor. This is one of the microchip product. This is the digital thermal sensor. In this I will briefly explain about this I2c in this video. Just watch carefully. I understand good in I understand well in I2c, so I can explain well in I2c. I will show it how it works and I will explain it well in this I2c. Here I already coded this. I didn't do anything right now. This simple code you can easy to understand. Now we will see first. Now we will see this design. Our design. Here you can see it. This is the SCL line and this is the SDA line. I think pin RC3 is the SCL line and RC4 is the SDA line in microchip PIC 16F877A microcontroller have. This two line is there. You can find out SCL SDA line in your data sheet, which pin is SCL and which pin is SDA. And I am pull up this two line to 5 volt. I am pull up because I will telling you it has some reason for making pull up this line. And this is a Tc74 sensor. This is sensor 1, sensor 2 and sensor 3 and sensor 4. 4 sensors are connected with parallelly the same line. I am just using SCL line and SDA line for this sensor. Also I am using the same line for this sensor also and this sensor also. Only two wires are shared with all the sensors. You can see it. It has no extra wires for from one sensor to another sensor. It is the two sensors is connected all the sensors parallelly, which means the sensor is connected all the sensors. The 4 sensors are connected with only 2 wires. So just think about it. If I put this sensor, just think about it. Just imagine if first sensor is in my bedroom and second sensor is in my kitchen and third sensor is in my out of home and fourth sensor is in my first floor. The temperature, room temperature is differ from another room. In kitchen side, if we made cooking, that time the room temperature is different from bedroom. So if I connected with my microcontroller and I make a simple display to measure the room temperatures and my home temperatures. One is outside my home and another one is first floor in any room, and another one is in my bedroom, another one is a kitchen. In this case, I just going two wire from microprocessor to connected with all the sensors parallelly. That sensor have only two line, SCL and SDA. The four sensor have only SDL line and SCA line, SCL line and SDA line. I just connected with this two wires parallelly all the sensors. Just think about it. If the temperature is differ from one sensor to another sensor, because the room temperature is different. So how can I read that different value in same wire? You got it? You got that question? You have in your mind right now. You got a question. I think see, which means all the sensor is connected in same wire. Then how can I get the different values? It has the all sensor is parallelly connected with my microcontroller. Then how can I discriminate? How can I get the value from one sensor? If just think about it, first sensor is providing 97.5 and second is 27, third is also here I'm just increasing, third is providing 32 and fourth is providing different 36. Right now all the sensor have a different temperatures. So how can I read it? This is providing 97, this is providing 27, this is providing 32, this is providing 36. So how can I read in same wire, in same line? It is possible. If I connected with if I using this ADC concept, then which one is high? That is only showing my microprocessor. That only I can get only that value. If this one is the highest value in this 4 sensor, so I get this value only. This is in ADC concept. So I can't get this temperature, different room temperatures. So in that concept, not for this only, it has a lot of future in I2c. I'm just saying example. For example, here is the two resistor are connected with pull-up, connected with directly pull-up with 5 volt, which means that this sensor have a internally simple circuit. This sensor is this is not a analog sensor. This is a digital sensor. This is a thermal sensor, but this is a digital sensor. How this is get the analog value from environment and then converted into digitally. It has a simple circuit inside this sensor and then transmit over the I2c network, I2c protocol. So this is a digital sensor. It will be send a digital value to the microprocessor. So that's why we are calling this is a digital sensor. In this case, the sensor only given the output 0. It doesn't send a 1 value. It doesn't send 1. It only send a 0 values. All the sensors send a 0 values for corresponding to the temperature. How can I read it? All the sensors sending 0. And how can I read it? How can I measure the different values, different temperature value? Yes, we can measure it. That is making these two resistors. If provide a 0, then if doesn't provide a 0, that time this is making 1. This line making 1, and this line also making 1, because this is defaultly connected with 5 volt. You understand it? And this is pulled up. So in this line is cut, that time the one is going inside the SCL line and SCA line. If that value is changing, that time the 0 is coming from this sensor. So this combination of 1 and 0 is converted into we can convert that temperature, digital from digital to we can convert the temperature. They are already providing that temperature range. See, you can see it. This is our data sheet. You can download it. You can Google it Tc74 thermal sensor for reference purpose. Here it is that here you need to study about I think it has 75 pages or 100 pages. I don't know. You need to study. I already studied about before 2-3 years back. In this case here, they said how the I2c functions are work, I2c protocols are work. It has all the brief definitions are there, and this is the one of the main format. Read format, read byte format, read format. I will explain in coding while we will move to coding section. That time I will explain. And here it is 1 and 0. If you send a 0, last bit is 0, that is write operation. If you send a 1, that is read operations. And then you can send a here it is, and then command bytes. Command bytes is configure the register configuration bytes. If you send a 1, that sensor will be standby mode. If you send a, which means 7th bit. If you send a 0, that time the sensor will be active normally. The 6th bit, if you send a 1, the sensor will be ready. If you send a 0, the sensor doesn't ready to send a data. Here it is, the hex value equal to the temperature. If plus 30 degrees Celsius or plus the temperature, actual temperature is 130 degrees Celsius, the registered temperature is plus 120 degrees Celsius. That time the binary hex value is 0, 1, 1, 1 and 4, 1, 1, 1. Okay, you got it. The actual temperature is right now 0 is, that time only the sensor will be providing this value. If minus 65 degrees Celsius, the actual temperature is minus, which means actual temperature means room temperature at present temperature, but registered temperature is minus 65 degrees Celsius. It is it's a very accurate sensor. Maybe 1 hour plus or minus something 1 hour degrees Celsius maybe differ, but this is a digital sensor. No, it's working good. If the room temperature is minus 65 degrees Celsius, that time the data will be maybe this one 10 11 11 11 11. This 8 bit will be we can read it. Okay, and this is the address of the sensor. How can I first I had a question I already asked about you. It has a 4 sensor. How can I discriminate? How can I identify it? This is the room temperature, this is our bedroom sensor, this is our kitchen sensor, this is our built-in in our first floor, and one sensor is outside of our house or our home. how can I identify it and get it the different values? Because these all are connected with parallelly in 2 line. All the sensor is connected with only 2 line. So how can I manage this? How can I get the if I want it my first floor room temperature, then how can I get it? How can I get it? Yes, it has an option, that is an I2c protocol. It has a simple I already told you, in this sensor have a simple circuit, in this sensor have a simple controller inside that sensor. So that sensor have a address. Every sensor have an address different. In I2c, if you choosing an I2c component, if you choosing an I2c based protocol based component, sensors or accelerometer like memories and like something, if you get a like an R2C chip, like memory chip, flash memory, or sensor like these kind of sensors, every sensors have a digital sensor have a some which means I2C protocol sensor have a simple memory, and that memory have an address, a specific address. That is, we can't set it, but we can program it. It already programmed by manufacturer. It already pre-programmed from factory. We can call it and use it. Think about it. This sensor address is 91, and this sensor address is 92, and this sensor is 93, 94. If I want this sensor, if I want if I want this sensor U4 sensor 91, 92, 93, 93, if I send a request from my processor, that time going this way, this is this sensor is checking, this is 91, 93, no, this is not 93, this is 93, no, this is not 93, this is 92, this is 91. So these two sensors skipped. These two sensors doesn't react for this two sensor doesn't respond for this master. Think about it. These all are slaves. This is only our processor, only the masters. These all are the slaves. These two slaves doesn't work because doesn't respond for this request. This is 93. Yeah, I'm 93. I'm sender. This will be sender. This will be going to send a response. This will be react for this request. Yes, I'm 93. Then what do you want? Then this another command byte send. This processor send another command byte. I want temperature right now. This bit temperatures. So okay. Then it will be going directly to this 93 sensor, 93 address sensor. Then it will be sent react or response the actual temperature already stored in this sensor. Then it will be send it to our processors. Otherwise, the other sensors are stay quiet. It's working, but doesn't send same time in the line. It will be sent the same time in this line. That is called a collision occurred. That time is collision occurred. This is called I2C protocol concept. Whenever you want the data, first you need to send that device address, then send a command byte, then again only you can get the response from that sensor. This is called I2C protocol. This is the concept of this I2C protocol. Here in coding section, I'm just putting this. You already know it. This view art. You can send the data through serially. and I1 added this new line, has use I2c master STA line and SCA line. Master means our processor is master. In this code is we are writing into the processor, so this is master. We need to tell about that. Okay, so that's why I said master. And then STA line, pin C4 is an STA line. You can see it. Pin C4 is an STA line and C3 is an SCL line, clock line. And I make a long int for storing data, data 1, data 2, data 3, data 4. I am making a function, simple function, easy to understand. I didn't make this code very simply, but you can't understand because we need to send I had another algorithm for this sensors, this I2c protocol, but now I am not showing to you because it can't able to understand this I2c protocols because you are a beginners. That's why I am making like this. The code is very lengthy. If you know well C, you can make a one simple function and then send an argument to this sensor, to this function, and then you can read the different values, different sensor values, different send and different address. So you can get the different data from different sensors. We can make it one simple function with arguments. Now I am not going to do like that. I'm just making four functions. One is for sensor 1 and 2 is for sensor 2, sensor 3, sensor 4, and just I am calling it this function and printing it the value of data 1, what is in value data 1, and then making delay and then call again function 2, which means sensor 2, then sensor 3, sensor 4, and printed that values, temperature values. Right now here it is the main code. Here I already told you in our data sheet. Here it is the read byte read mode. We will make it read mode. We just now read the temperature from that sensor. So we will see this start. S means start. I2c start. I am starting I2c function. It is already function, a library function, and 7-bit address. 7-bit address means 90. This is address for this first sensor. You can see it, the address of this sensors. A0 100100. The last bit I already said to you. If you put a 0 here, that time the address, the mode is write mode. The sensor is going to write. If you put a last bit is 1, that time the sensor can, the processor can read from that sensor. So okay, you got it. If you put a 0, that is called write mode. If you put an 1, you can read it from read the value from that sensor. Okay. Okay, here it is. First I2c start 7-bit address. Here it is given the 7-bit address only. Here it's a 7-bit 0 1 2 3 4 5 6 7-bit only. So which is 9 1 0 0 1 1 8 4 2 1. This is 9 and this is 0. And again we add the 0 because here it is we make it here this right bit, so we add a 0, so 1 0 0 1 0 0 0 0. So totally 9, so 8 bit, but the value is 9, hexa value is 9, so I am putting here 9. 90. Okay. Then send a command byte. The command bits, 1 byte, that is here. Standby mode and normal mode, 1 is ready, 0, which means 0 to 7 bit, 0 to 7 bits are there. 1 byte, 7 and 6 bits are we make it. Another bytes already reserved, so we don't want to use it. Okay. 1, if you send an 1, that sensor will be standby. That sensor doesn't react. If you send a 0, which means 8 bit, 7th bit, then it will be react. If you send a 1, the sensor is ready, and if you send a 0, that sensor doesn't ready. It doesn't. It is. I think it's going busy. If I send a 0 into 02, just make it a hexa calculation from binary to convert hexa to binary, 02, and then need a repeated start. Here it is. I send a command, then the sensor will be acknowledging every time. If in this process, after finishing this process, the sensor will be sending acknowledgement, that is 0. Acknowledgement is 0 only. It doesn't send a 1. It is only send a 0. And then command byte, and we will get acknowledgement. For our acknowledgement, if the data will be going to reach that our sensor, if reach or not, we can't identify. So the acknowledgement will be respond through the I2c line. Then again we will start. Here it is. I started. I2c started after sending command bytes. Then send an address. Again I send an address 90, but it has last bit is read. I already told you 1 is read, so I am just putting 90 already 90 in write mode. Then read mode 91. Okay, you got it. I just added 1. Read mode. Then I got an acknowledgement. Then the sensor is ready to respond. So I just read it and put it my into my variable. Put into a variable. I just read it the data from that sensor, and then I make it stop. The last bit is 1. If I get the data from that sensor, it doesn't acknowledge because that is send data. So it is send not acknowledge. Then stop bit, P is for stop. So I just put a stop. Okay. This is also same, but address may be differ. This 90 and 91, 92, 93 for writing, for reading, for writing, for reading. Okay, for writing, for reading. The last bit only 1 or 0 may be differ for write and read. So then I got put into data 4, data 3, data 2, data 1 in different variables. Then I will, in my main loop, I will just print it, call it that function, total function, and then print it that data 1 value, data 1 variable, and making some delay, and another sensor I am calling it, another function I am calling it, and then put into data 2 and printing it and making delay and calling another function and printing another that variable, what is inside that inside and that variable. This is repeatedly doing repeatedly. Right now we will check it how it's work. Here it is. You can see it. But okay, you can see the overall structure, overall circuit. This the terminal. Okay. You got it, all the temperature sensors reading. Here it is, I'm running it. See it. First sensor values 100, second sensor values 27, third sensor values 32, and the fourth is 36. Okay, if I change this one only changing, doesn't affect any other sensors. 100, 27, 32, 36. See right now, the third sensor only changing at 2 from reach maximum range, but this sensor is 100 displaying, this sensor is 27, and fourth sensor is 36 still. While this is increasing, that time another sensors doesn't make anything, not sending any value to the processors. When it calls, that time only the sensor will be react, because I am using address, so that's why another sensors are stay quiet, doesn't respond with the processor. See, when I will reduce the third sensor temperature manually. Got it? It is going to negative value, minus 90, 198. You got it? I am putting into 0 the third sensor value. You got it? You can you got it right now? Yeah, right now this is 0. And just fourth sensor is increasing, 87, 130, and second sensor I am going to reduce, 91, now 35, now 55, and fourth sensor is first sensor is 130. So now I am going to reduce, 84, now 72 in this case, 72. See, in this case all the sensors are connected in only 2 wires. So this is the beauty of I2C protocol. Just go through it. If you want to see this code, I'm scrolling it slowly. Just download my this video, and then slowly typing it and check it, it's working or not working. It's working properly. And then before you start this I2C implementation, you need to download this Tc74 sensor from, just Google it, Tc74 thermal sensor, digital thermal sensor. Okay, just close it now. Close it. Okay. Thank you for watching. I think I made a good video. I made a good videos for you. Thank you for watching. Please subscribe my channel. Thank you.